cool. We are going to take a machine learning model and turn it into a live web application that you can deploy to the internet, all in under an hour. By the end of this webinar, you will have a working AI app running on your laptop, a deployed version live on the internet, a GitHub repo you can clone and modify, and most importantly, a story to tell in your interviews and resume. Let's do this. And coming to a quick intro, I'm Omkar. I'm an AML mentor here at Data Valley. I have been built and deployed over 5 different AI applications, keeping it all apart. But here's the most important thing. Most webinars will teach you just theory. Today, we are skipping theory. We are going practical. In the next 45 minutes, here is exactly what we'll build a tiny ML model. I'm not talking complex neural networks. I'm talking a simple, elegant classifier that really works. And next, we'll wrap that model in an API so it becomes a web service that anyone on the internet can call. Next, we'll deploy it live on Vercel or Render free platforms that handle the heavy lifting for us. And then we'll do question and answers where I'll show you how to talk about this in interviews and what to learn next. Sound good, right? So let's go. Before we start, a quick poll for you. What's your experience level with ML? Just answer honestly. This tells me how deep to go into theory. We're going to keep this very hands-on. So even if you never heard of it, you will totally follow along. So okay. So before we jump into code, let me show you the big picture architecture diagram. This is the journey of data in our application. So the first one goes with data. We start with a data set. Think like customer reviews, sensor readings, images, whatever we want to learn from. This data feeds our model. Next, pre-processing. We clean it up, removing missing values, normalizing numbers, make sure it's in the right format. And next, model. This is the brain. We feed the clean data to a machine learning model and it learns patterns. In our case, something simple like logistic regression or a decision tree. In like 5 seconds, it learns to make predictions. And next, coming with API. Here's the magic. We wrap our model in an API. Basically, we are saying, hey, when someone sends a request here, use my model to predict and send back an answer. Next, coming with to the front end. Could be a nice UI actually in React, or today we'll just use some Postman to test it. Either way, the API doesn't care it. Just process a request. And coming to the next step, deploy. We push this to the cloud, maybe Vercel or Render, wherever, and boom, your app is live. Anyone on the internet can now hit your API. Makes sense, right? This flow is like data, train model, wrap in API, deploy, live on internet. Now let's actually build this. Here I created one collab already, one collab notebook. I'll be sharing you the collab notebook now. So yeah, sharing you the collab notebook now. Yeah, here we go with the collab notebook. So all right, let's build our first ML model. I have already set up a Google collab notebook with the data label loaded. Let me screen share it. Okay, so this is our data set. I'm using iris dataset where we will get about the flowers. And this dataset consists of 4 features: sepal length, width, and etc. And 3 flower types we need to classify. In real world, as you can take an example, like you could use customer reviews or medical data or anything. The code always stays the same. Here, let me explain you the codes here. So coming to the first cell, you can see I have imported everything we need, like pandas for data, sklearn for the model, and nothing fancy here. So next, go to the next cell. Here we loaded the data. I loaded the data from into an iris variable, and in the x-axis I took the data like the features like sepal length, width, petal length, and width. And in the y I took the target which we need to predict, like the flower type. We call it 0, 1, 2 as we have 3 types. And for now I printed the data, the data set shape, and the classes we have. So as we see here in the output, the data shape is 150 and 4, and in the classes we have setosa, versicolor, and virginica. Okay, so these are the different classes we have, and the target is we loaded everything like the first to show you the first 5 rows. I have printed the head from the data frame. I loaded the data into the data frame, and I used the pandas to uh, load into the data frame, and from the data frame I printed the data we have. And next, coming to the next cell, we have splitting of the data into training and testing. For building model, we need a training set and a test set. So from the training set, the model learns from the everything, the data, like it takes the data, it trains on the data iteratively, and this test data is used to test the model's accuracy or the output, how well it is predicting. So I have split the whole data into in 8 is to 8 is to 2 ratio. So here we go X train, X test, Y train, Y test, and we used the train test split function directly from the sklearn. And see, test size I have mentioned 0.2. So the other 0.8 goes to the training one. And the random state is 42 for having a clear picking of the data. And I have printed the training samples count and the test samples count. And here we go with 120 samples into training and 30 samples into test. Next, I have trained a logistic regression model. I have used the sklearn for it, and I have trained it using the X train and Y train. Maximum iterations are 200. So it around for training this model, it iterates over 200 times, and it creates a model, a logistic regression model, and it successfully model is trained now. And next, coming to the predictions. So I have told you the model predicts from the test set. So here we take the X test, and we are asking the model to predict using that X test, and here we got in the Y pred. And next, accuracy. I think something, yeah, here it is loading, and that's why we couldn't get it out. See, model was trained. And next, coming to calculate the accuracy. We need accuracy to know how well our model is actually giving output. So into the accuracy variable, I took the accuracy score function, and I have passed the Y test and Y pred into it, and I just printed the accuracy. And here we can see we got 100% accuracy. Because this is a smaller model, we can get 100% accuracy. But coming to the large models, large data sets, and a complex training models, we will not get 100% accuracy all the time. Okay, and this is the classification report. Like I have trained the model, right? So based on class, I need a classification